Hello everyone. A project named Severity of Diabetic Retinopathy using deep learning under the guidance of Dr. Kamalakar sir. Our team members are Rohit, Nityanayani, Rosary Arvind, Shakti Coming to abstract, the human eye is considered as the most important sense organ. Some of the eye's problem may be curable, but few may lead to permanent loss of vision. Commonly occurring diseases such as optic nerve disorder, such as glaucoma, destruction of sharp vision, such as age-related macular degeneration, diabetic eye problems like retinopathy, etc. This project focuses on the detection of diabetic retinopathy. Coming to the problem identification, traditional methods of DR detection involve manual examination of retinal images by trained ophthalmologists, which is time consuming and resource intensive. This project aims to develop an automated system for the detection of diabetic retinopathy using advanced image processing and machine learning techniques.
This is the difference between normal and healthy eye. In the normal eye, there are no blood dots. The supply of the blood to the retina is normal and everything like a healthy eye. So in a diabetic retina eye, there is a leakage in the blood vessels, and this causes some leakage of blood vessels and leaks the fluid into the leaks the fluid to the blood vessels which supply blood to the retina. So this causes a blindness in the diabetic patients. There are different shades of diabetic retinopathy. So we have mentioned there is mild non-proliferative retinopathy, moderate, severe, and proliferative. The existing system on this project is which is handled by manually ophthalmologists, and the images are taken from the laboratory. So many existing systems rely on manually automated. This process is time consuming and cost efficient. It costs very expensive in laboratories, so that most of the diabetic patients cannot afford this.
Coming to the proposed system, the goal of this automated model is to detect the severity of the disease present in the diabetic patients. It helps in finding early diagnosis and prevents the damage caused due to diabetic retinopathy. Using our system, it takes very less time for detecting the disease. Bringing out a good accuracy with the different machine learning algorithms is the aim of the project. Coming to the technologies used, we used convolutional neural networks (CNN). It is a branch of deep learning having an impressive record for applications in image analysis and interpretation, including medical imaging. Network architectures designed to work with image data. The key algorithms utilized include deep CNN data augmentation and hyperparameter tuning. Next, this is the dataset which we have applied for our project, which uses for the training of the model. These images are in black and white, so that we have applied Gaussian filter for the best training of the model to predict the diabetic retinopathy.
Coming to our literature review, identify keywords. Begin by identifying a set of keywords with phrases closely related to the project, such as detection of diabetic retinopathy, proliferative, non-proliferative, etc. These keywords will serve as a basic for conducting your literature search. Search database. Utilizing academic database like IEEE Explore to search file research papers and articles relevant to your project focus. Review abstraction. Thoroughly examine the abstract of identified papers to gain an overview of the research work. Based on abstract, shortlist paper that appears directly relevant to the detection of diabetic retinopathy. This step will help to focus on the most relevant research. Compare methodologies. Analyze the various methodologies and techniques used in the literature of detection of diabetic retinopathy. Compare to the pros and cons of different approaches such as deep learning based methods, traditional image processing techniques, and hybrid models to determine the most suitable approach for your project. Consider data. Pay attention to the data. Pay attention to the dataset utilized in the review literature. Evaluate the size, diversity, and relevance of the datasets on your specified detection of diabetic retinopathy, consider whether the datasets cover variations in lighting conditions. Note innovations. Take note of any innovative techniques, enhancement, or novel ideas presented in the literature. These innovations can provide valuable insights and creative solutions to enhance our proposed system.
This is the window which shows the interface of our project, which is showing to upload an image for the prediction of diabetes retinopathy.
Next slide.
This is one of our window of our interface which shows the types of diabetic retinopathy are present. This is a window showing the information regarding diabetic retinopathy. This is the window after the prediction of given input image. It is defined as the mild DR in the retina.
This is the code we have implemented for our project. Eye chart representation. Here we are predicting by giving it an input image. It is predicted as severe. I'm saving the model as model.json. This is the code which we have implemented for our interface web page. And we have given starting templates. First system. External pages. This is a data set. We have divided into 5 different types according to DRs. This belongs to mild. This is moderate. No DR, it's a normal retinal image. Proliferative DR. And this is severe DR. We have applied Gaussian filter for it. We're gonna run this to see the output of the project. So here we have to upload our input image. This shows about diabetic retinopathy information. What are the types in it? So we are choosing a random. The output is the image has been classified as mild. All this, the images we have, which we have given, will be saved into this folder.